Today we're going to be graphing cosecant and secant graphs, but to do that we first have to know how to graph sine and cosine functions, so I made a review of it. This is your standard cosine and sine function. Obviously it can vary, there can be a plus or a minus here, a plus or a minus there. The A stands for altitude, which is the maximum deviation from the sinusoidal axis. This right here is the sinusoidal axis, which is halfway in between the max and the minimum, and the deviation is how far above or below the sinusoidal axis we are, and that is the altitude. B equals period variation, which is how far the graph is stretched or shrank horizontally. A period can go from max to max or min to min. A period, you can find it by dividing 2 pi by b. To find the units on the x-axis that label where the max and the minimums are and where the graph hits the sinusoidal axis, you're going to take the period divided by 4. D equals the vertical shift from the x-axis. If, for example, it goes up 1 unit, the sinusoidal axis is going to move up 1 unit. If it went down 2 units, it would go down 2 units. Here we have a graph 2 sine x that doesn't have a vertical shift, and it looks like this. And here we have a graph 2 sine x plus 1, which does have a vertical shift up 1, and the sinusoidal axis moved up 1 unit. C equals the horizontal shift from the y-axis. X plus c equals a shift towards the left. X minus c equals a shift towards the right. Here we have a graph 2 sine x, which doesn't have any horizontal shifts. Here we have 2 graphs with horizontal shifts. One is 2 sine x plus 1, so it moved to the left 1 unit. Here we have a graph 2 sine x minus 1, which moved to the right 1 unit. Now we're going to graph secant and cosecant functions. If you have a function with secant in it, you're going to graph cosine first. If you have a function with cosecant in it, you're going to graph sine first. The reason we can do this is because cosine equals 1 over secant and sine equals 1 over cosecant. Here's an example, y equals 4 cosecant 2x plus 1. First, we're going to have to graph it as a sine function. The altitude is 4, b is 2, so p equals pi. C equals 2, and D equals 1. First, we're going to graph it. I find my points. And I find the sinusoidal axis, which is going to be at 1. Then I connect those points. And we have our sine function graph. The second step is to find the asymptotes. These are lines that the graph approaches but doesn't touch. An asymptote usually looks like this, a dotted line, and the graph will approach it but won't touch it. To find the asymptotes on this graph, we have to find the points that the graph hit the sinusoidal axis, which one of them is right here. So we're going to draw a line going downward that hits that point. And we do this for every point that hits the sinusoidal axis. In this case, the y-axis would be an asymptote because the graph hits the sinusoidal axis on the y-axis. The third step will be to draw y equals 4 cosecant 2x plus 1 as a graph. These will be parabolas meeting the maximums and minimums of 4 sine 2x plus 1. The max of this will be the minimum of this, and the minimum of this will be the maximum of this. Basically, we're going to draw these parabolas and avoid the asymptotes that are drawn. So here's my first maximum that I'm going to draw off of, and I'm avoiding each one of these asymptotes. And as you can see, this is the minimum to this parabola, and this is the maximum to this graph. The fourth step will be erase the y equals 4 sine 2x plus 1 graph, and you have the finished product of y equals 4 cosecant 2x plus 1. So this is what the finished product would look like.